the range of sin inverse x plus cos inverse x plus tan inverse x. Here, three different kinds of functions are there, namely, one is sin inverse x, another is cos inverse x, and third one is tan inverse x. Actually, find the range means whenever we are having different kinds of functions, first we have to find the common domain. In this common domain, we have to find the range. This is the concept. For example, two functions are given. For finding the range, first you find the common domain of given two functions. It is the standard procedure. Okay. Sin inverse x, it is in inverse trigonometric functions. Sin inverse x domain closed interval of -1, 1, and its domain is also closed interval of -1, 1, and its domain is a real number set. X belongs to capital R. Here capital R means total real line. Infinite numbers are there, out of which so it is 0, -1, next +1. So total R means total line. Next closed interval of -1 means this is closed interval of -1 +1 area. So where is blue and black shade, common shade? The common shaded part is closed interval of -1, +1. Therefore, if f of x is equal to sin inverse x plus cos inverse x plus tan inverse x, then the common domain of f of x is closed interval of -1, 1. That is x belongs to closed interval of -1, 1. That is -1 less than or equal to x less than or equal to 1. Okay. Later apply tan inverse on both sides. It is tan inverse of -1 less than or equal to tan inverse of x less than or equal to tan inverse of 1. Actually, tan inverse of -x equal to minus tan inverse x means minus tan inverse of 1 less than or equal to tan inverse of x less than or equal to plus tan inverse of 1. So that implies minus tan inverse of 1 value pi/4 less than or equal to tan inverse of x less than or equal to pi/4. How? You come here. Tan pi/4 in tan pi/4 that is equals to 1. In inverse trigonometric functions, it implies that pi/4 that is equal to tan inverse of, right side we are writing inverse function, tan inverse of 1. Thus tan inverse of 1 is equal to pi/4. Okay, this is one useful value or statement. Next, you come to f of x. F of x is equal to, given that sin inverse x plus cos inverse x plus tan inverse x. So that is equal to, in inverse trigonometric function, we have one tremendous formula. In its domain, sin inverse x plus cos inverse x value is equal to pi/2 plus the remaining function tan inverse of x. Therefore, simply f of x is equal to pi/2 plus tan inverse of x. Now we have to find the range of pi/2 plus tan inverse x. So already we derived here minus pi/4 less than or equal to tan inverse x less than or equal to plus pi/4. So for getting pi/2 plus tan inverse x equal to f of x, we are adding pi/2 throughout the inequation. So minus pi/4 plus 2 less than or equal to pi by 2 plus tan inverse x less than or equal to pi by 2 plus pi by 4. This is the adding pi by 2 throughout the equation. So that implies it is pi by 4 less than or equal to this much is f of x less than or equal to pi by 4 means 3 pi by 4. This is 3 on simplification. We are getting 3 pi by 4. So therefore what does it mean? F of x that is belongs to is equal is there. That's why I wrote closed interval. So it is pi by 4 comma 3 pi by 4 means what? This lower bound is the minimum value of f of x. It is called minimum value. This one is called maximum value. Therefore, in the common domain, therefore in common domain, that is x belongs to closed interval of -1 comma 1, the range of f of x is closed interval of pi by 4 comma 3 pi by 4. So clearly which option is right? You come here, second option is right. This is some important question. Here the given function is e power ix, means it is in Euler form. So f of x is equal to e power I theta means 2x. Actually e power I theta is equal to cos theta plus I sin theta. So that is equal to cos 2x plus I sin 2x. This is f of x. Okay. Next, here capital R stands for real number set. Capital C stands for complex number set. Here we have to introduce a new word, periodic function and its period. Let us consider. So before going to give the inference or correct option, it is better to know the word periodic function. Actually, let us take f of x is equal to sin x, trigonometric function, sin x. So f of, let us consider f of x plus 2 pi is what? It is sin of 2 pi plus instead of x we are writing 2 pi plus x. So 2 pi plus x. 2 pi means 360. Sin of 360 plus theta is equal to sin theta. This is sin x. We are getting same function f of x. 2 pi plus means in quadrants it is 2 pi plus means it is in first quadrant. Similarly 2 pi plus another 2 pi means 4 pi plus. This is 4 pi plus area. So therefore f of x plus 4 pi is equal to sin of 4 pi plus x. It is also sin x, that is equal to f of x. Okay. Similarly, we can write number of values 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, just like that. So therefore, what I am telling that if the domain means x plus 2 pi means x plus 2 pi is equal to sin x. For 2 pi, 4 pi, just like that, 4 pi, 6 pi, and so on. For every number, different number, we are assigning the same value in the second set or image set, just like that. We are getting the same value, same image. So therefore, out of out of 2 pi, 4 pi, 6 pi, and so on, infinite numbers are there. The least number, the least number is equal to 2 pi. This least number 2 pi is called period of f of x. So therefore, the trigonometric function sin x has the period as 2 pi, So what is happening here? F of x plus something lambda is again becoming f of x. Here lambda is what? Lambda is a least number, So therefore, what I am telling that if this condition is satisfied, then f of x is called as periodic function, and its period is equal to lambda. Its period is lambda. So once again, if f of x is any function, if f of x plus lambda is equal to f of x, means if there exists a least number lambda, so that f of x plus lambda is equal to f of x, then this f of x is said to be a periodic function and lambda is called its period. So it is happening the same here. So therefore, which one is the least number? 2 pi. So f of x plus 2 pi equal to f of x. F of 4 pi equal to f of x plus 4 pi equal to f of x, and so on. So out of which the least number is 2 pi. Therefore, this condition is satisfied for sin x. That's why sin x is a periodic function, and its period is equal to the least number is 2 pi. Okay. Similarly, we can show that cos x is a periodic function. Its period is 2 pi. Its period is also 2 pi. Next, sin x periodic function. Its period is 2 pi. Similarly, cos means its reciprocal secant x. Its reciprocal is cosecant x. So therefore, sin, cos, secant, cosecant, these are periodic functions and its period is 2 pi. And similarly, tan x, we can show that tan x is also periodic function. Its period is pi, and cot x is also periodic function. Its period is pi. Thus, all 6 trigonometric functions are periodic function, but its period is different. For example, sine, cos, secant, cosecant, the period of these 4 trigonometric ratios is 2 pi, but tan cot period is pi. This is the small synopsis of periodicity or periodic function or period. Okay, you can ask me, sir, what is the need of introducing this word periodic? Here we observe that this function is means in the domain set. This is the code domain. In domain set, so many elements are mapped with only one element, just like that. So it is many to one function. So therefore, what I am telling that sin x is not one function in its domain capital R. So many to one function. So therefore, sin x. Similarly, sin kx, not only sin x, but also sin kx is also a periodic function. Similarly, cos also periodic function. So what I am telling that every periodic function, every final result, every periodic function is a many to one function, means but not one function. come here. Here f of x is cos 2x real part. This is the real part. This will be imaginary part IP. Real part, imaginary part. Cos x periodic function. Sin x is periodic function. Therefore, f of x very clearly f of x is a periodic function. Therefore, f of x is not one function. Is not one function. Okay, half of the part is over. Next, we have to think of onto function. The nature of onto function. Okay, 1 minute. Onto function means what? You come here. In the codomain, each and every element will have at least one pre-image in the domain set. This is onto function. Otherwise, it is called as into function. Okay, here you come here. This is the domain. Domain means what? Capital R. This is codomain. Codomain means complex numbers. Here we are having all the numbers are complex numbers. Here all the numbers are real numbers. Remember, in this theory, point number 1, every real number can be expressed as a complex number. For example, let us take 3. 3 equal to 3 plus I into 0. We can write like that. So, if any number which is expressed as in the form of x plus iy, of course x comma y belongs to capital R, then it is called a complex number. So, every real number, for example 0 is a real number, root 2 is a real number, root 3 is a real number, minus root 2 is a real number. Minus root 2 is equal to minus root 2 plus I into 0. So, therefore, every real number can be expressed as a complex number. But every complex number cannot be expressed as a real number. For example, let us take 3 plus 2i. It cannot be expressed as a real number. Remember. Understand? Okay. You come here. For example, complex number. Is it expressed as a real number? Or, I will put one question. For this complex number will have at least one pre-image in the domain? No. Answer is no. Therefore, here we are having in the second set, we are having all the complex numbers. Definitely, these all complex numbers cannot be expressed as a real number. Means what? Cannot have the pre-image in the first set. That's why it is not onto function. Of course, it is into function. It is out of question. So therefore, due to this reason, f is not onto function. Therefore, f is neither 1 nor onto function. So clearly, which option is right? Fourth option is right. Hence the problem. Moreover, about the periodic functions, already I discussed sin x function about the periodicity. Here, what I am telling that sin of 2 pi plus x is equal to sin x. Means we are trying to express the form f of x plus pi lambda. F of x plus lambda is equal to f of x. Then f of x is said to be periodic function, and lambda, the least number lambda, is called its period. Okay, sin of 2 pi plus x equal to sin x. Here sin x means its domain, actual domain is equal to real number set, and range is equal to closed interval of -1 to +1, -1 and +1. Okay, already we did know very well about the domain and range of f of x. Here domain means capital R, range is equal to closed interval of -1 comma +1. What I am telling that for 2 pi, for example, sin 30, how much? Sin 30 degrees is equal to 1 by 2. Okay, I am telling that sin of 2 pi plus 30 degrees. 30 degrees means what? Pi by 6. That is also equal to 1 by 2. And sin of 4 pi plus 30 degrees is also 1 by 2. 4 pi. So this is 2 pi. Next another round 4 pi. Next another round 6 pi. 6 pi. Sin of 6 pi plus pi by 6 is also 1 by 2, and so on. So means what? 6 pi, 4 pi, 6 pi, 2 pi, 4 pi, 6 pi, and so on. These infinite numbers are mapped with only one element. It is what? 1 by 2. 1 by 2. Remember, this 1 by 2 is belongs to closed interval of -1 comma 1. This is called many to 1 function. Many to 1 function means a function is not 1 to 1. Similarly, in cos also, cos, what I said, cos of 2 pi plus x is equal to cos x. Means let us take one number, cos 30 degrees. Cos 30 degrees is what? Cos 30 degrees equal to root 3 by 2. Root 3 by 2. Similarly, what I am telling that cos of 2 pi plus 30 degrees is also root 3 by 2. Next, cos of 4 pi plus 30 degrees is also same value, root 3 by 2. And next, cos of 6 pi plus 30 degrees is also root 3 by 2, and so on. Infinite values are there. Means what? In cos x function, this is cos x function, domain is capital R, next range is same -1 comma 1. Here 2 pi, for example 2 pi means 22 by 7, already you did know, it is approximation value. 2 pi, 4 pi, 6 pi, and so on, just like that. All these kind of infinite values are mapped with only root 3 by 2. Of course, root 3, 1.73, root 3 by 2 means 0.85 something. So root 3 by 2 is approximate equal to 0.85, just like that. Okay, root 3 by 2, it is also belongs to this range, -1 comma 1. So therefore, many values, many elements, many members are mapped with only one value. It is called many to one function. Many to one function. Many to one function. Thus, it is not one function. So ultimately, sin x is the periodic function. This condition, due to this condition, sin x is periodic function and cos x is periodic function. Similarly, sin, cos, tan, cot, secant, cosecant, all trigonometric 6 ratios or functions are periodic functions. And sin x, next cos x, it's reciprocal cosecant x, secant x, for these four kinds of functions, the period is 2 pi, and tan comma cot, these are also periodic function, and its period is pi. Its period is pi. So at present, so therefore, what I am telling that since these are periodic function, therefore they are many to one functions. Therefore, what I am telling that finally, every periodic function is a many to one function, but not one function. Similarly, we can show for tan. For example, tan 30 degrees equal to 1 by root 3. I am telling that tan of pi plus 30 degrees is also 1 by root 3. Thus, 30 degrees pi by 6, next pi plus pi by 6, pi plus pi by 6. Pi plus pi by 6 means that 7 pi by 6, 7 pi by 6, 7 pi by 6 and so on. That kind of infinite numbers are mapped with only 1 by root 3. So therefore this is also called as many to one function. Therefore it is a periodic function, and thus it is many to one function, but not one function. Similarly, we can show that for cortex function. So therefore, number 1 point, we have to note the point number 1. All trigonometric ratios or functions are periodic function, and all periodic functions are not one function. They are many to one function, and the period of sine, cosecant, cos, secant is 2 pi, but the period of tan and cot is pi only. That's all. Here, capital M is a set of all 2 by 2 matrices, and function is defined as capital M to capital R. Capital R means real number set. And f of A defined as determinant of A. A is what? Capital A is any 2 by 2 matrix in the set capital M. Means what? M. This is the set. Its name is capital M. This is real number set. It is the domain. This will be co-domain. This will be co-domain. Here, for example, let us take, for example, capital M1. Its name is R. We can take capital A1. Capital A1 is 2 by 2 matrix in capital M. Let us take matrix of 0, 0, 1, 1. Now, it is what? It is about determinant of its matrix. He said like that, det A, f of A equal to det A means, what is determinant? 0, 0. That is equal determinant of A1, or simply we can write determinant of A1. Means it is mapped with 0. He said like that. Next, let us take another 2 by 2 matrix just like that. Another different matrix 0, 0, 0, 1. It is also different matrix with real numbers as members. So 0, 0, 0, 1, these are real numbers. Okay. What about this determinant 0? Already I said determinant of A, B, C, D is equal to AD minus BC. So using that, AD 0 into 1, 0 minus 0. So it is also 0. So it is also mapped with 0. That is also equal to determinant of A2 matrix. Similarly, so many infinite matrices we can create here 2 by 2 matrices so that its determinant equal to 0. Or we can write, you can ask me, sir, it is 0 matrix 0, 0, 0, 0. Its determinant is also 0. Why? Because 0 is a real number. So therefore, f, it is the function f. So clearly, f is not one function. F is not one function. Next, for every real number, actually this is the set of real numbers. For example, one real number is there, definitely this number will be of the determinant of something, any matrix, 2 by 2 matrix in capital M set. Thus, every real number will have at least one image in capital M. So therefore, every element of capital R, that is codomain, will act as the image of the element of first set or pre-image set. Thus, F is onto function. Onto function means what? Every real number will be the image of at least any one matrix in capital M. Thus, F is not one function, but it is onto function. So, which option is right? It is onto, but not one function. Second option is right.